Hello everyone. Quick video for you on complex numbers. I think that we've done some of these before. I don't remember though. Okay, so this is a separate sheet of paper. I didn't obviously do the one you're supposed to do. So when we graph complex numbers on the complex plane, the first number is our A value, which is our real number. And the second number is our imaginary or our complex number. So we're gonna graph it like we would graph an XY regardless. So this is actually -1, 4. So it's gonna be up here. That's it, that's all, okay? Obviously, -3, 2 will be here. Sorry, I'm looking through the phone, so it's taking me a long time. Now, there's other ones like this that have like a cosine and sine, but they're on the rectangular plane. Ignore those, that doesn't, I don't wanna do that. If I were to graph on here, it's the same process, but the cosine and sine is the same, which means I'm looking for 5 pi over 6, and I'm looking for the 6th radius or the 6th ring. So 5 pi over 6 is here. These are by 2, so it's gonna look a little funky. So it's right here, okay? Same thing with number 4. 2 root 7 is really ugly though, so just estimate it, okay? All right, find the absolute value. Absolute value is, it's like magnitude, right? It's gonna be, it's x squared and y squared, that kind of stuff, and the square root of it. So it's gonna be 6 squared, this phone is not focusing and it sucks. Okay, so 6 squared. So you see this? 6 squared plus 3 squared, ignore the negative, right? So that's 36 plus 9, which is 45. But it's the square root of 45. So your answer is what here? It's 3 root 5. So the absolute value is 3 root 5. So it's like magnitude. We have to have positives. Same thing here. It'd be 2 squared plus 4 squared and square root of that, okay? Magnitude of this thing. We've actually seen this before. The magnitude of the absolute value is 4. It's just 4, okay? Here, guess what? It's just 6. That's all that is. Okay, now, when we have exponents, this is called De Moivre's theorem. I don't know if we talked about this or not. When it's in the complex form, meaning not polar, you really want to put this entire thing on the calculator. You can put I in the calculator. If you can put this in the calculator, it's going to give you a value. Now, this one specifically, because it's only a square, if you wanted to area model it, then do that, okay? The answer would be, what's the answer? -15 plus 8i. So this is -15 plus 8i. Again, you can actually FOIL that because it's only a 2. We use the De Moivre's theorem when it's greater than 2 because this is actually like Pascal's triangles type stuff. So just put this whole thing in the calculator and you get your answer. The answer to that is -54 minus 54i. And I'll show you that in a second. Okay, -54 minus 54i. All right, now when it is in polar form or trig form, this is actually really simple. The 2 exponent distributes as an exponent to the magnitude, and then you multiply it times the cosine and sine values. So this is gonna end up to be 2 squared, which is 4, and then cosine 600 plus I sine 600. That's the answer. Okay, so it works really nicely when it's in trig form because all we're really doing is we are distributing the exponent as an exponent to the magnitude, and we are multiplying the values next to cosine and sine. So this is gonna be root 13 to the 3rd power, which is 13 root 13, and then 3 times 315, which is like 945. So your answer for number 12 would be 13 root 13, or whatever you got. We could just simplify it, because it's, you know, 13, root 13 times root 13 times root 13. And then it's gonna be cosine, I don't know what that is, 945 plus I sine 945, okay? So that's the worksheet. Again, don't do the ones for graphing where it's on polar, but it gives you rectangular. It's weird, all right? Really super easy. See you later.